Hello, everybody. Today we're going to be talking about Newton's laws. The first law we're going to get into is the law of inertia. And it states that a body or an object, either at rest or in motion with constant velocity, will remain that way until a net force acts upon it. This means that if you have an object and you don't move it, then it won't move. And we obviously observe this every day. Your bed doesn't move unless you apply force to it. And I think it's important to talk about the second part, which is in motion with constant velocity. If a car is not accelerating, so let's say it goes from 50 miles an hour to 55, then 60, and it stays that way, then it's going to continue increasing its speed incrementally 5 miles an hour, and nothing is going to stop it unless it has a net force acting upon it, like it hits a wall or something. But when they say constant velocity, this means that there is no acceleration, because acceleration means the velocity is increasing. Now, it's important to talk about friction. When imagine an object in space, if you move it and you push it, it's going to infinitely keep moving in space until the end of time. In Earth, that doesn't happen because of friction. And there are two types of friction. We have static friction, and this friction exists between a stationary object and the surface upon which it rests. So imagine that you have a cabinet and you want to move it. If you try moving it, you feel like there's resistance against your push, and that's because of static friction. And static friction only exists until you start moving the object. Then it gets converted to kinetic friction. And kinetic friction is between an object that is moving or sliding and the surface upon which it lies. So concrete or some other surface. It's important that you realize that static friction is always higher than kinetic friction. It's much easier to continue pushing an object that's already moving than trying to get it to move. So static friction has a formula which is called Fs, and that's less than or equal to the coefficient of static friction times the n, which is the component of the force between two objects in contact. And this is basically between, like, imagine an object on Earth. It's the thing that keeps you from sinking into the ground. It's the push. It's the opposite push of gravity, and I'll explain that more later. So this formula has less than or equal, unlike the kinetic friction. This is because you have to apply a certain amount of force to push an object. If you have a refrigerator and you try moving it, unless you put in an adequate amount of force, it's not going to move. And that's why it's less than or equal, because static friction matches that applied force until a certain extent. After that, it changes to kinetic friction, and then the object starts moving. So to get an object to move, you have to give it enough force that it surpasses the static friction. Kinetic friction is equal though. It does not matter how much force you're putting in, it's always the same thing. It's always constant, and it's also always lower than static friction. Now, let's get into the second law. The second law basically can be summed up to F net is equal to ma. What does that mean? That means the net amount of forces is equal to mass times acceleration. So the best way to understand this is by looking at an object. Imagine here that you have a cube. You want to move it. You have to apply a force, and that depends on the mass and the acceleration of the object, how much force you're putting in. So imagine that you have an object that is 1 kilogram and you try pushing it with, let's say, 10 newtons of force. This is gonna move it a good amount. If it was, for example, 10 kilograms, then the acceleration would be much slower, and that makes sense. Um, it's much harder to push an object that's heavier if you're applying the same amount of force. Now, the law states that an object of mass m will accelerate when the sum of the forces results in some non-zero resultant force vector. It's important. It's useful to look at the fact they mention resultant force. So if if I'm trying to move this object, and let's say I barely put in any force, like I'm just touching it, it's not gonna move. Why? It's because the static friction goes against my force. So it goes against it. So you have to give a stronger amount of force to counteract the static friction to get the object to move. And a good way to memorize this formula is to think of this triangle where F is on top, M is bottom, as well as acceleration. So if you want to find out how much mass there is and you know the force as well as acceleration, you would just be M equal F over A. Now, the last force we're going to talk about is the third law. And the third law is pretty simple. It states that for every action, there is an equal but opposite reaction. If I have an object right here and I apply a force to it, the object is going to apply that same amount of force to me. So if you imagine that it's slippery and you're trying to move an object, a lot of the times you get pushed back when you're trying to push him. Same thing happens in space. When you're trying to move an object, you end up getting pushed too. Why does this not happen that much in reality? That's because there's static friction helps like keep us in place. So when you are pushing, let's say, a ball, you get pushed the same amount, but it's just so negligible because you're a lot of the times you're bigger than the ball. But even if the ball is bigger than you, a lot of the times static friction is going to keep you in place. Those are the three laws. The second law is very high yield, and I've seen it come up on a lot of questions, especially knowing the units, and it comes up with kinematics. So keep that in mind.